Hello and welcome, everyone. Thank you so much for joining us. I'm going to re-add the Slack link into the chat. Please join the Linkerd Slack if you haven't had a chance. We have a workshops channel where you can go and discuss stuff with the folks that are doing the workshop, as well as some folks from Buoyant who can answer questions as we go. Today, we're talking about running Linkerd in production. We've got Charles. Charles, you might go to the next slide. Okay, Stephen. Well, it's workshops with an S. You have to specifically join the channel. So we have Charles Pretzer here, who's actually going to be leading this workshop, right? So he is a principal field engineer here at Buoyant. He is an expert in getting folks able to be successful with Linkerd and has learned all of the tips and tricks over the years. You can find him on GitHub and Slack and Twitter. And he'll talk a little bit more about himself as he gets going. Today, we're going to tell you about the workshop and then go through everything from the checklist, what you need to know to monitor, debug, and how you're going to handle upgrades. A little bit about this, right? We are putting on a series of these workshops and we're calling them the Service Mesh Academy. And there'll be a bit more announcements about that coming up soon. Today, we're talking about the basics, what you need to know to go to prod. And there's some assumption that you already know a little bit about Linkerd and a little bit about Kubernetes. There are lots of 101 materials that we're happy to share with you. And if you ask for that in the workshop Slack, I'll point you at plenty of resources. No, that's fine. We can go to the next slide. It all covers an article that we published, which is our production run book, and we'll send that in the chat as well. Thank you so much, Stephen. What's not covered, right? Again, the basics or really advanced topics in Linkerd. And those will have their own workshops later. All right, and with that, I'm going to hand you over to Charles to learn how to get to production with Linkerd. Take it away, Charles.
Hello, everybody. Thank you for joining us, making this a truly global workshop. It's so great to have you all here. This is going to be a very informative talk, in my opinion. As Jason mentioned, everything that we're talking about comes from our Linkerd run book, which is based off of the experiences and the ongoing experiences that we have with folks in the Linkerd community, as well as Buoyant customers. We saw the agenda, so now we can just jump right into what it takes to go to production. And what we put together here is an essential productionization checklist. There are a few things. If you run Linkerd or kick the tires on Linkerd, you know that you can deploy it with the CLI. Comes with its own Prometheus. A lot of very simple and easy things to get you started, which are part of the core design principles for Linkerd. This going to production workshop is going to talk about the next step, where we dive into what it's like to set up a cluster to run in production. Well, once you have a production cluster, we talk about deploying Linkerd to that cluster. And this checklist is something that you can use to get you started. We've got a companion repository that goes along with this. And I believe the link was sent in the email that y'all sent. If you've got the link to the repository, you'll see a file in there called create.sh. It's going to do some dependency checks, and then it will, as long as you've got all the necessary binaries, it will deploy the cluster for you. I encourage you, if you're going to follow along in the workshop, to do that sooner rather than later. We've got probably 10 or 15 minutes before we get to the hands-on section. So you want to make sure that that cluster is up and running if you want to follow along. With that being said, the reason I bring up that script is because it sets up in your local environment what would be a production type of environment. The create script deploys Linkerd using Helm, not the Linkerd install command, and it deploys it in high availability mode. If you look at the script, you'll see that I've added a couple of custom configurations to enable the debug log levels for the control plane components. And that's something that we'll take a look at in the hands-on part. In addition to those two items, going down this checklist, you'll want to use your own image registry. And we'll talk about that in another slide coming up. We'll set up monitoring and alerting. We'll discuss that as well. And then the rest of these topics, understanding how to debug Linkerd, that's going to be our hands-on part, and understanding how to install and upgrade Linkerd. Again, we'll cover that. So the thing that we're not covering in this workshop is planning for and documenting your certificate management. Certificate management is one of those advanced topics that Jason just mentioned that we'll be covering separately. So this is your basic checklist. I promise you with this, you can get to production and have a happy, healthy cluster running with all of the observability, security, and reliability features that you're used to from Linkerd. When we talk about high availability mode, what we're doing is the values-ha.yaml file, which is in the repository in the Linkerd chart, deploys 3 replicas of the critical control plane components. Today, that for Linkerd 2.11, that's the destination controller, the proxy injector, and the service profile, or the identity component. And so within the destination component, there are some multiple containers. That's not relevant for high availability mode. What's important to know is that in a production type environment, you should have at least 3 nodes that are going to be handling traffic, which means typically you don't want to deploy any Linkerd control plane components to your Kubernetes control plane node. So even though the script that I have creates 3 nodes, typically a production environment would have at least 4 nodes, and then you deploy Linkerd in HA mode, which means then that you get 1 of each of the Linkerd control plane components on each node, so that in the event of a failure of one of those nodes, you still have, or 2 of those nodes, you still have 1 or 2 of the control plane component replicas running. And high availability is a fairly common topic. So the point here is to eliminate single points of failure. In high availability mode, we need to make sure that the proxy injector is up before any of the injected pods, your application pods, can be injected with the Linkerd proxy. The way that this works is that there's a webhook that detects whether a workload should be injected with the Linkerd proxy, and that proxy injector has to be up and running and healthy in order to do the work that it needs to do to inject the proxy YAML into your pod definition. High availability mode also includes node anti-affinity, which means that when we have these 3 replicas, and the reason that we need a minimum of 3 nodes is because there will be no single node will have more than 1 replica of each of the control plane components. So this anti-affinity ensures that, again, the separation of the responsibilities, that those control plane components, in the event of node failure, will still be, a control plane will be up and running. And finally, it sets resource requests and limits on control plane components. What we've got set in our values-ha.yaml file is kind of the basics for running in production. We've certainly seen through working with other members of the community and other companies that sometimes these resource requests and limits need to be adjusted based off of your workload. I'll talk about that a little bit more when we get into the monitoring and alerting section of this workshop. And finally, one of the requirements that you'll see in the create.sh file is that we add a label to the kube system namespace as a whole. You don't want Linkerd to inject the pods in your kube system namespace. We treat those as being very sacred, and so you don't want, Linkerd shouldn't be handling the traffic for kube system. So we add a special label there, config.linkerd.io, admission webhooks equals disabled to the kube system namespace, again, to make sure that those pods are not injected. Technically, you can use this label on any namespace that you want. We only require it for kube system. I mentioned earlier about using your own image registry. The main reason for this is because you don't want to rely on a public registry for downloading your images. In a production environment, you want to make sure things are up and running. When those images are being pulled, you want to make sure that they are there, that they're reliable. And the best way to do that is to run your own registry that you have control over, so that if something goes wrong there, or if it's down for some reason, you can lean over to the person that you're working with, or whoever, send an email to or Slack message to one of your coworkers and say, can you check on this registry? It seems to not be working. We need those images. So the process here is pretty straightforward, and it's also what we don't cover here is automating it, but it can be done very easily with scripting, where you would do a Docker pull from the Linkerd repository anytime a release is out, usually a stable release, but if you're using edges, that's great. And then you would Docker pull from the public repository, Docker push to your image repository. Very straightforward. If you have any questions about this, please drop them into Slack. Okay, let's jump into monitoring Linkerd. This workshop is all about checklists. So we've got another checklist for you for monitoring. And when we're talking about monitoring, this is separate from the observability features that we often associate with monitoring with Linkerd when you're monitoring your application itself. What we're talking about is monitoring the Linkerd control plane. So the first thing we want to do is figure out where you're going to put your metrics. Again, if you've used Linkerd in the past or in a development environment, you know that deploying Linkerd Viz or previous versions of Linkerd in the control plane, we included an instance of Prometheus, and we still do that today in Linkerd Viz. This is meant for development purposes only. When you are running in production, you're going to want to have those metrics available to you for much longer periods than what Linkerd Prometheus offers, and you'll also want them to be stored permanently. And so one of the things that we want to make sure that you're doing is figure out where you're putting your metrics. You can put them into an off-cluster resource like an external Prometheus, either cloud hosted or one that you run yourself. Or there are plenty of third-party choices like Buoyant Cloud, Datadog, New Relic. I've seen folks put them into, I believe Splunk even, you can store stuff there. So plenty of options for you. We don't have any, we want you to use what is going to be best for you. So that being said, Buoyant Cloud will do a lot of this for you, including the next item on the checklist, which is alerting on control plane and data plane components. So one of the main things that we want to understand is in any application is the health of the services themselves. And so the Linkerd components, like any other container or service that runs code, you want to make sure that those are healthy. And for the most part, the Linkerd control plane components should always be 100% healthy. If they aren't, we want to know why, and that's where the alerting comes in. So there are options that you can use to set those up as well. Again, there are so many that we're not going to cover any one in particular here. One of the other things we want to make sure that you understand and that I touched on just a minute ago is that the latency and resource usage need to be determined empirically. And that goes back to setting those resource limits in the values -ha file. So I'll show you an example in just a second of what one of the Linkerd control plane components looks like with a well-known number of workloads and requests per second. These are things that you're going to have to suss out for yourself in your own environment based off of the number of replicas, the number of workloads, the amount of traffic that you have in order to understand what those limits need to be set at. And then you can set the alerts appropriately. And finally, TLS certificate expirations you want to alert on as well. If your certificates expire while you're running, while the cluster or Linkerd is running or the whole cluster is running, that is real bad. So it's important to understand, give yourself enough time. We mark with Linkerd check, we look for certificates that expire within 60 days. This is just a guideline, but we definitely suggest that you pick a duration that matches your team, that gives them time to go in and rotate those certificates and then alert on that appropriately. So here we see, when we're talking about alerting, we see alerts inside of Buoyant Cloud. And there are alerts that are set here based off of success rates and P95 latencies. And we've allocated we've categorized them as SEB2, SEB3. And so just at the top here, we see that if the success rate for the Linkerd destination component, we're going to pick on the destination component a lot today. If that ever goes below 99%, send me a SEB2 alert. We also have one on latency. So if the latency is ever greater than 50 milliseconds, send me a SEB2 alert. This is an example of the kind of alerting that you want. And again, the things that you will have to decide empirically based off of your application's performance and resource usage. Here, we see some graphs that are part of Buoyant Cloud. And I told you just a minute ago that we would give you a concrete example about the amount of resources that are used based off of the number of workloads and latency within an application, or sorry, throughput. So this is a real life example of a medium cluster. We can see that the destination component is using roughly 820 megabytes of memory. The proxy injector is using roughly 420 megabytes, and the identity component is using roughly 165 megabytes. The CPU for all of these is below 0.02 usage or cores. And this is based off of about 500 pods and 2,000 requests per second. So by understanding your throughput, your requests per second, and the number of pods that you have running, this will be either bigger or smaller, and you can adjust those resource limits appropriately so that the Kubernetes doesn't go in and evict those pods based for using too many resources. So I wish that I could say, here's a formula that will get it done for you. But unfortunately, applications are so different. Usage by workloads, by services is so different across applications that there is no silver bullet for these things. So you'll have to do some iterating and figure out which resource limits and requests are appropriate for your environment. It's an investment that's worth doing, and there are no secrets to it. It's very straightforward once you understand the profile of your application. So if there are any questions about that, again, please drop them into Slack or in the chat, and we'll keep moving on here into the debugging section. So you should have, if you haven't already, now would be the time to run that create script to get your cluster up and running, because after the next few slides, that's when I'm going to jump into the hands-on part of the workshop. Because debugging Linkerd is, when I'm not doing workshops or presentations or working with some of the folks on the team here, I'm usually chatting with somebody in Slack or working with one of our customers, helping them through Linkerd issues or debugging Linkerd to understand what's happening within their environment. So we have a number of tools, and the purpose of this section is to present to you the tools that you can use to debug the Linkerd control plane. This is different than some of the other talks that we've done, where we use Linkerd to debug your application itself. In this case, we're treating the Linkerd control plane as the application, and we're going to use some tools to understand what's happening in the event that the control plane is acting up, or even the data plane, for that matter. So you can debug the Linkerd control plane, start by debugging it using the tools that you already use and are familiar with today. Two of those are, well, one of the tools is kubectl, and two of the commands that it has are kubectl events and kubectl logs. Anytime that you see a control plane component that is in a state other than running, that's where I would, when I'm debugging with customers or with Linkerd community, the first thing that I'll look at is the output from kubectl get events for the Linkerd namespace specifically. And this is what we'll look at in the hands-on section. This will tell you if there is a problem communicating with the API server. In some cases, it'll tell you if and that can happen for many different reasons. But the events are a good place to start, and oftentimes we'll have the message to point you to the solution that you need in order to get the control plane into a healthy state and get those pods up and running. And oftentimes in conjunction with kube control events, we can identify a specific workload or specific pod that isn't starting up for some reason. And we can also see that in the pod status. And we can use kube control logs to view the container logs. Now, I mentioned in the create script, my values-ha.yaml file has a couple of configurations custom for this particular deployment. And those configurations are to set the log levels of the control plane components to trace log levels, which can be pretty verbose. So this is not normally something that I would do in production, but for the purposes of this workshop, for us to be able to see A, what it's like to specify a custom configuration file, and B, to be able to look at those logs without having to go in and restart some pods or any of the workloads. In a production environment, you would leave those log levels where they are. And if an event happened, we would then go in and set those log levels to something that's will output more information for us so that we can then use kube control logs to view those container logs. Going beyond the basics, we've got the Linkerd CLI. So we mentioned that we're not going to use the Linkerd CLI to install Linkerd. What we are going to use the Linkerd CLI is for the debugging process. So for those tools, and we'll walk through each of these in the hands-on part. We've got Linkerd check, Linkerd diagnostics, Linkerd viz tap, Linkerd identity, and Linkerd auth-z. I'll go through each of these in just a few minutes. I mentioned log levels earlier. There are two places, because you've got the control plane and the data plane, we have the ability to control log levels in each one of those. The log levels that I just mentioned in my values-ha.yaml configuration file, actually, sorry, that's a values.yaml file. It are for the control plane configuration. The proxy log levels, you have multiple ways of configuring those. One is globally in the Helm chart, and this is generally in a production environment. I wouldn't do this, but it's possible to do. The reason for this is because when you're debugging data plane components, you don't necessarily need to have all of the proxies set to a verbose log level like trace or debug. You really are looking at one workload and the replicas within that. And so for that, we can use a per workload or per namespace through the annotation config.linkerd.io proxy log level. And in this case, I've got it set to warn, which is for all of the Rust components, the crates. Those will be set to warn, which is a less verbose level. And then anything in the Linkerd 2 proxy namespace will have a trace log level, which is very verbose. And again, this is not something that I would run in production for a long time, but it is a tool that we've used in the past and that we frequently use to understand the traffic that the Linkerd proxy is handling, both on the inbound side when it's receiving requests and on the outbound side. So one of the really neat things, one of my favorite things about the Linkerd proxy is that you can actually configure this at runtime. We're not going to do this today, but if the Linkerd proxy has a configuration endpoint, the Linkerd admin endpoint, and when you port forward to that port, you can send a put request that will set that uses the same syntax, this Rust syntax for setting log levels. And in this case, we're setting Linkerd equal debug, which means any Linkerd crate within the proxy, we're going to set that to debug, and we send that put request, and that will configure the proxy log level in real time. And this is super helpful when we see one particular proxy acting up within a set of replicas. So that's indicative of an event that is not systemic, meaning that the service itself is fine. There's just one replica that's acting up. And so this gives us some really fine grained control here. So going from top to bottom, we can set everything. We can set for a specific workload or all the pods in a namespace, or we can set the proxy log level at a specific container. And so this is very valuable, very helpful. And I can't count on my hands the number of times that I've worked through this with folks and even done this myself. The control plane components, I mentioned these earlier. The only real takeaway that you want from this slide is that the policy controller, which is new in 2.11, is written in Rust. And so it uses that same Rust syntax, Linkerd equals info, comma, warn. The other components that are written in Go have a more probably familiar syntax for setting the proxy log level, where you specify just the name, error, warn, info, debug, and trace. And that's from left to right, that is least verbose to most verbose. And just like the proxy log level, you can set them globally in the Helm chart, which is what I've done in that values.yaml file in the repository, or you can do it per workload by modifying the individual Helm templates. So that is the basics of debugging the Linkerd control plane. One other thing that I want to mention to you is that we have this Linkerd debug sidecar, which is a really powerful tool, but with great responsibility, with great power comes great responsibility, I think is how they say it. And so this has to be run as a root user, but it's a container that has tshark, tcpdump, lsof, and iproute2 binaries. And so I've used this with folks to capture TCP dump packets and inspect those packets individually when there's something that's really, really funky going on. This is, I don't want to call it a last ditch effort, but this is when you're using the Linkerd debug sidecar, it's really powerful. And it's something that we're using when we're really down in the weeds, trying to understand that packet level communication. Oftentimes, actually all the time, when it's between the Linkerd proxy and the service container, Linkerd proxy container and service container within the same pod. So we're looking a lot of times at just that localhost traffic that's happening between within a pod itself, between two containers. There's a link here for you to explore more. Again, really powerful tool. And we mention it here because we're talking about overall toolkits and what's available to us. So with that, let's jump into the hands-on section. I'm going to jump over to my terminal here. Oh,
Hey,
sorry,
Charles,
yeah.
Sorry to interrupt. Just wanted to ask folks who are listening. One, we've had a super active chat, so thank you very much. Does anyone have any questions for Charles before we go further?
I'm going to take a sip of water. Yeah.
Yeah. Good water break time. All right. Sorry to interrupt you, Charles. I think we can carry on. Thanks, folks. And again, continue to ask stuff in the chat. Love to help you and make sure that you're able to successfully complete the demo.
Yeah. Great. So I showed you that we the create script. So there's nothing magical going on here. This is just a very quick and dirty script to get you started. This is a bit difficult to read, but what we're doing here, there are some important parts here. Give me 1 second to pull over my my editor, because it's going to be easier to read in there. There we go. Okay, so this is the debugging steps. We want to look at the create script. There we go. Much easier to read. I'll make it a little bit bigger.
Charles,
okay,
a couple people who are doing the create script have said that they need to independently run the command helm repo add linkerd. So Stephen posted about that in the chat, and there's also some commentary in the workshop if you're following along.
I haven't looked, but I will. Yeah, that's a good point. We do check to see if Helm is installed, but because I already have the Linkerd repo added to my machine, I failed to add that check. So PRs are welcome. If not, I'll get it fixed right after this. I see some other chats in there. Thanks, Stephen. Appreciate the PR. Just want to walk you through this quickly. The checks for the binaries are straightforward. What we create is three servers, a 3-node cluster using K3D. And then we create our certificates. So we talked before about certificate management. The important thing to know here is that when you deploy Linkerd using Helm, you can't, we have to specify our own certificates, which is different from the Linkerd CLI. And again, what's important here is to understand that there's a trust anchor, which is this CA cert and CA key. And from that CA cert and CA key or certificate and key are the issuer certificate and key, which are created as leaf certificates. We'll cover all those in the upcoming workshop about certificate management. Important thing to know here is that when we do Helm install, we have to make sure that we provide those to the Helm, as values to the Helm file or Helm installation command. The other thing to take note of here is that I also added the namespace label for Cube system, just to show you that it's there and that it has to be done. However you end up configuring this in your CI/CD system, you'll just want to make sure that you add that label at some point. Yeah, so that's that script. Very simple. And again, a similar thing for deploying Linkerd viz. I've put these out into two separate scripts just to make them a little more easy to comprehend and wrap your mind around. They could be in the same script if we wanted them to. So I'm going to take a quick look into the chat to make sure that there's nobody who, or that everybody is at least be able to get started.
There was another reminder from Nathan. A couple of folks have run into an issue on Mac OS where the script uses the date command and the Mac OS has gdate. So we'll post something about that in the workshop Slack as well. But you may need to do an edit if you're on Mac OS.
Good point. And our docs actually have the command for generating the date for both Mac OS and Linux. This is a Linux script, but we will get that updated as well to do some iOS detection, or sorry, OS detection. Thanks for pointing that out. Okay, I also have created this. Let's look at debugging.md. This is kind of a quick and dirty cheat sheet for all of the commands that I mentioned in the slides. So if we take a quick look at the events that I mentioned, we'll go in order of the most, the cube control commands through the Linkerd commands, and then that'll be those are the steps that we'll go through. So first thing I want to do is look at the events for the Linkerd namespace. What I find really helpful is to sort by last timestamp, otherwise they get all jumbled up. But in this case, oh, no resource found in Linkerd namespace. Oh, you know why? Because you'll see that I was working last night and there have been, all the events have expired since then. So I'll just do a restart these deployments. And while that's happening, we can take a look at some of the other parts of the script. And so actually, I should have events now already. And again, the only reason I did that is because the previous events in there had expired. We want to get some new events so that we can actually see that what's going on here. And this is what a healthy set of events looks like when the Linkerd control plane is starting. Aside from the killing, because I've restarted the pods, but you'll see created, started, pulled. If there's anything, one of the things that we want to look for when debugging the control plane is anything that is not normal. So here we have a warning. This is failed scheduling, just based off of the anti-affinity rules. That's because all the pods were already running and some on the nodes, and one needed to be terminated before another could be started. So when you're using kube control events, anything that's not normal is going to be something that you want to stand out, that you want to look at, and you know, sort by timestamp. That's going to make your life much easier rather than having to go through and look at when a message was last. or an event was last written. Okay, so next thing I want to get into is the logs. And so I'm going to pick on the identity pod today. Grab one of our replicas out of the namespace here. Linkerd namespace. This is one of the identity replicas that's running. And what we're going to do is, oops, wrong window. Sorry about that. What we're going to do is we'll get the logs for each of the containers within the identity component. There's the Linkerd identity component itself, and that's responsible for issuing certificates to when it receives a certificate signing request from a proxy, then it signs that certificate and sends it back to the proxy, and that's used for mutual TLS. There's also the Linkerd proxy itself, so that tells us when it's handling inbound and outbound traffic. And then another one that sometimes we have to debug, but not often, is the Linkerd init container, and that's responsible for setting the IP tables rules. A lot of times when we see issues with components not being able to communicate with each other, we have to take a look at the IP tables rules and the output from the Linkerd init script to make sure that the pods that those IP table rules were set up correctly. So let me we'll look at the logs for the identity component, specifically the, oops, you probably can't see the Zoom toolbar that's in the way there, but it is preventing me from typing. I'm kidding. My bad typing is because my fingers don't work well in the morning. Kube control logs, Linkerd identity -n Linkerd, and if I do this without specifying a container, oops, what did I do? It's just kube control logs, isn't it? I put the git in there. So another fix on my side, I will get that done. So if we don't specify a container, you've probably seen this before. We need to specify a container. I often do this just to see which containers are available. So first we'll look at identity, and there's nothing abnormal happening here. But what I want to show you is that we can confirm that our log levels have been set because we see that these debug messages are in there. By default, the Linkerd control plane components will will log, I believe, just info messages. And so here we can see that debug is set. In fact, oops, let's see. What I want to look at is, well, we don't need to do that today. I was just going to show you, if I looked at the manifest file for the deployment and grepped for the log level, we would be able to see that the log levels were set to the values in my values-ha.yaml file. So that is what the identity component logs. In trace mode, it will tell you anytime a certificate has been requested, where it's been requested, which proxy has requested it, and the associated service, as well as the identity associated with that service. And it will tell you that it has issued that certificate, or in the case where it's not issuing certificates, it will tell you that why it hasn't issued the certificate. So this is a valuable tool for understanding how proxies receive their certificates, and if for some reason they aren't, we can debug the identity component. Let's take a look at some of the Linkerd proxy logs. Linkerd-proxy, and this is again a very typical startup for a Linkerd proxy. If you're debugging something that's actually actively receiving traffic, the trace level output is like, you can't read it because the screen is moving too quickly. So again, this is something that we do for a short period of time. We capture those logs somewhere where we can, typically what happens is we see bad behavior, we see unexpected behavior, we set the log level, we reproduce the behavior, unset the log level, and then analyze those logs. So that's the typical debugging workflow that I work through with folks in the community and with our customers. And finally, just because I want to show you what the init container logs, the script itself outputs all of the IP table rules. So it tells you what the current state of IP tables is. And here we see that there were no IP tables that were already set. This can be different if you've got multiple init containers and that are manipulating IP tables. And that's one of the reasons that we write those IP tables first, to be able to debug any potential conflicts or routing issues from other containers. And then it actually writes all of the commands, the actual IP tables commands that are used by the Linkerd proxy. And finally, it shows you the output from the IP tables once everything is done. So this is a really once the script is run completely. So this is a really helpful tool in understanding some low-level IP tables, routing, network behavior that happens within the pod itself. So that's the basics of using kubectl logs and kubectl get events. Let's jump into the Linkerd CLI for debugging. I'll run through these quickly. We've got Linkerd check. This is the basic, like if anything goes wrong with the Linkerd control plane, we want to run Linkerd check. This is going to keep running. It checks the extensions as well, if any extensions are deployed. And if there's anything in here that's unexpected, then it's going to tell you. For example, my control plane proxies are not running the current version. And I think this is a bug that was fixed in a recent edge. Let's see, we've got Linkerd check, Linkerd version. Linkerd diagnostics is a really powerful tool. So let me get another, let's see what I have. Yeah, perfect. Okay. So we want to do Linkerd. Let me move this up so it's more readable. DG is short for diagnostics. We want to get proxy metrics. And sorry, I've lost it behind Zoom again. Let me make this a little bit smaller. Okay. And we want to get it off of that identity pod. So this is going to give you the raw metrics for raw Prometheus metrics. And where we use this a lot is looking at the TCP connections. So it's a bit difficult to read, but here, if we see something where connections are being refused or by the pod, a lot of times what we'll look at is the TCP closed total compared to the, let's see, TCP open. There's a TCP open total. Having a hard time seeing it here. Sorry about that. Oh, here we go. TCP open total. We compare that with TCP closed total. If there's a big disparity, we know that there are a bunch of open connections, and we also display the open connections. So this is a tool that I've used to debug issues where we see connections being refused or closed by the service container. Another one that I want to go through is the Linkerd identity command. And this gives you the ability to inspect directly the certificates that are associated with a Linkerd proxy. And so here we see the identity component there are 3 identity components or replicas of the identity component, and the certificates that it's using. It shows our common name. Again, this is an inspection of the certificate. It will tell you when it expires. We'll use this to check to make sure that the certificates are healthy in the event that 2 pods can't communicate with each other. Finally, new in Linkerd 2.11 is the Linkerd auth-z command. And this tells you all of the, server authorizations and server CRDs that are currently active in your environment. And so this is specifically for controlling policy and understanding when, looking at policy and understanding which policies are in place and which pods can communicate with each other, or which services can communicate with each other. So in this case, we can see that we've got servers and authorizations for all of the components in the Linkerd viz namespace. And if we were to look at those separately, we would be able to look at what's allowed and denied. That's all part of a different workshop. We also have I think we did we went over it in one of the community meetings. I think it was September, October, where we talked about policies and understanding how the syntax behind those. So those are the main tools for debugging using Linkerd CLI. In some cases, we've had to dig into the kubelet logs for seasoned Kubernetes operators. This is something that it's never comfortable, but it should be something that you understand how to do. Looking at the kubelet logs themselves to see if there's anything going on in the system that looks suspicious. So that is how we debug Linkerd, the control plane, and the data plane in production. Let's jump back over to our slides, and I hope you're all able to follow along with that. I know that apologies that the script was Linux focused. I hope that you all will be able to follow along on your own. So let's take a quick look at upgrading and rolling back, and then we'll jump into some questions. So upgrading Linkerd, so this is another checklist. We just forgot to put the word checklist there. Always test in lower environments. This is nothing new here. The data plane is designed to work with future control planes. So you upgrade the control plane first, and then gradually restart the pods that are meshed with Linkerd so that they get the new version of the proxy. So really good example of this is here we show upgrading 2.10.2 to 2.11.1. You upgrade the control plane to 2.11.1. Those proxies that are running the 2.10.2 control plane will still function. And as you, on your own time, you can go through and roll those out, restart those workloads so that those pods get the 2.11.1 proxy. So the compatibility is there. That's one of the key features that is tested for when a new version of Linkerd is being built, whether it's an edge or a stable. One of the questions we get a lot is upgrading Linkerd, and one of the things I've seen happen is folks will leapfrog versions. Always, 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 please, always upgrade sequentially. So if you're on 2.9, go to 2.10, then 2.11. Don't jump 2.10 to get to 2.11. This is just because there are changes that happen across versions, and we document these all very well in the upgrade notes. And if there's anything in there, anything that happens, like specifically a breaking change, then it will be documented in there, and you'll be able to understand what needs to happen as you upgrade, any additional changes that you need to make. Or if it's just a seamless upgrade, then it'll say, yeah, let's just go ahead and upgrade. But the main thing is don't skip versions, because there may be special notes for each of the releases. One quick note about upgrading with Helm is that there are some flags that you should become familiar with. I only learned about these recently myself. We document them well in the upgrade docs. Reuse values and reset values are flags that are part of the Helm binary. And I've created a little table here. When you have the matrix is whether you want to reuse values or reset values can be driven by the decision of whether you've got any configuration overrides or if you're using vanilla Linkerd as configured out of the box. Have a look at these, have a look at the docs. For the most part, the default behavior is fine. I haven't seen a ton of people, actually, I've never seen anybody ask questions about these particular flags. So most of the time, you'll be able to Helm upgrade without having to specify any of these flags, which means that there's a default behavior that occurs. Reuse values is the default behavior if there are overrides, and reset values if there are overrides. And the difference between the two is reuse values will take what's currently in the configuration and apply it in so much as it can to the the new version, and reset values takes the configuration from the release, so 2.11.1. If you use reset values, will overwrite the values, anything that's in the 2.10.2 release. So that's upgrading. And rolling back, it's fundamentally the same as upgrading with Helm. There's one little gotcha with Helm that just I have always have a hard time wrapping my brain around, is that you can Helm upgrade to a previous version. It's just Helm semantics. If you can Helm upgrade from 2.11 to 2.10.2, and everything will work as expected. I will point out again, breaking changes are documented in the Helm upgrade guide. And I know I mentioned earlier that you should use version control for your Helm configuration files, but this is going to help you a ton if you need to do any rollbacks. So that's the basics for rolling back. There's not a ton to talk about here. And with that, I think we've covered everything from monitoring and alerting, as well as being able to identifying and using the tools for debugging Linkerd, the data plane and the control plane, and upgrades and rollbacks. We'll be handling questions throughout the day in the workshops channel, and going forward, I hope that folks have been able to get their questions answered during the chat. Let's take a minute and the next few minutes. Jason, do you have any questions for me that I didn't cover that you think would be helpful for the folks here? Or are there some interesting questions that you saw come in that we should answer?
Yeah, good one from Nathan. In general, is it safe to Helm rollback the control plane if you want to roll back in a hurry?
What is in a hurry? Yeah. Yeah, so to me, that means you've just upgraded from 2.10 to 2.11, let's say, and you've decided that you want to roll back to 2.10. Yes, for me, I think that's totally fine. The thing to think about there is whether you have rolled any of the data plane components. Any of the data plane components. So if any of the proxies have been upgraded to 2.11 in that example, you want to make sure that as soon as you've rolled back to 2.10, you also restart those workloads as well to get back those proxies back to 2.10.2. In most cases, that will work. The proxies will work in that. I'm trying to think. I shouldn't make that blanket statement. Make sure that the proxies are at the version of your control plane or lower for compatibility's sake.
Right. And we have another good one from Shumit, I believe, and I'm sorry if I mispronounced your name. If I have set up Linkerd using the CLI, what is the best way to move it to a Helm-based deployment?
Good question. So if you've set up Linkerd using the CLI and you let Linkerd generate the certificates for you, then you're in a situation where you'll want to rotate those certificates out, including the trust anchor, which is why we need to have the workshop for certificate management. Off the top of my head, you will, if you're in a position to, I would redeploy Linkerd from scratch with Helm. It's probably the most seamless route, but not everybody's in that position, and I totally get that. So the things that I would do is create those new certificates or get the certificates from your organization security team, and then go through the steps for manually rotating the certificates, the trust anchor specifically. And then when you Helm deploy, you would specify those certificates as well.
Okay, and so folks who are listening, there are documents on the Linkerd docs that discuss exactly how you would go through rotating the certificates within Linkerd, and so that's what Charles is referring to there.
Yep. I'm trying to think. No, so actually, I ran through this exercise yesterday where I did a Helm deployment with one certificate and then did Helm upgrade with a different certificate. And as you can see, the problem there is that you now have mismatched certificates in the proxies and in the control plane, which means the trust is broken and the system wouldn't work. So you want to make sure that you have those certificates in place before you do any upgrading using Helm from the Linkerd CLI.
Right. Yeah, and Demetrius actually was really helpful and posted the link for everyone. Thank you so much for that, Demetrius.
Yeah, it's awesome. Thank you. What else, Jason?
We have a couple. We have one that we're not going to touch because it's a roadmap one regarding Linkerd and Kiali. So Morton, we can talk about that a little bit offline. For folks that are joining, right? Like we're about at time, but would love to have you join the Linkerd Slack, and I'm going to post that one more time. The link to join our Slack, and feel free to reach out to myself or Charles anytime, and also come to that workshops channel to just ask us about anything you saw in today's workshop.
And that's also the place to get updates about upcoming workshops as well.
Yeah, and so with that, why don't we plug the next workshop in the series?
You got it. Next workshop.
Let me post the link to Slack. I'm so sorry about that. So go ahead, Charles.
No problem. Next workshop is locking down your Kubernetes cluster with Linkerd. So we'll talk more about security here. That's going to happen on January 13th, which is a Thursday, and all the times are there. So register today, and we look forward to seeing you there. We love doing these workshops, and I can't remember if Jason mentioned this earlier, but as we started the Service Mesh Academy series, we're basing it off of the feedback that you all give us. So when you ask questions about Linkerd or specifically fill out the form to say, this is what I want to learn about, we take that and we say, people are asking a lot about running Linkerd in production and how do I debug it? Let's do that workshop. So please continue to give us your ideas. Tell us what you want to hear about. And we're also interested in some of the edge cases out there that might be fun to track down that other people may be running into as well. So yeah, I'll leave it at that. Thank you so much for joining. Thank you for being members of the Service Mesh Academy. I'm pretty excited for these workshops, and we look forward to doing more and seeing you all there.
Yeah, thank you so much, everyone. Great.